Okay, so for today we are going to start with quantum numbers, right? So one thing I want you to tell me, what are the quantum numbers? What do you think about the quantum numbers? So any of you have seen an atom? Tell me, any of you, tell me guys, any of you, have you ever seen an atom in the real life? You can reply me either on chat box or you can open your mic and just tell me, because the session must be interactive. Interactive means it should be the two-way communication. I'm asking you something and you should reply me something, right? It's not like your normal daily class in your university, like the teacher is explaining and just you are accepting and writing in your notebook, explaining the ppts and everything. No, it's a different session. It's a very different thing from that. Okay, here I will ask you something and you will tell me whatever I will ask, right? So now tell me, have you ever seen an atom? Where does where you can see an atom? Anyone? Have you tried to see an atom either in microscope or something? Not really. Very good. Yeah, so it means that we can not directly see the atom. So one thing, we are studying from since childhood, we are studying like atom. Yeah, okay, atom has a proton and a neutron, and the electron is revolving around the nucleus. This is the thing what we study since we are child, right? And that is the same, and that is the true. How we can say that? We did some experiments, and after doing those experiments we got the conclusion that yes, this is an atom. An atom has a proton, electron and neutron. Now your chapter 6 and 7, especially chapter 6 and 7, it explains you, my friend. Okay, I accept that the electron is present inside the atom, but where it is? Wallah, you have money in, okay, you have money, you have dirhams in your pocket, but I don't know in which pocket you do have, right? So that is exactly I want to ask to any atom. Hey atom, tell me, where is your electron? So the quantum numbers will tell you where the electron is present inside the atom. Did you got my point? Quantum numbers, see, the quantum numbers is very big topic, but for your syllabus it's very small one. Okay, so I'm just explaining you from the beginning of anything. Quantum numbers explains, or it tells you, how does the electron exist inside the atom and where it is. Quantum numbers has a wide applications. How? It tells you where is the electron inside the atom. It tells you where is the this atom. For example, we talk about the iron, or any atom. Okay, so where it exists in the periodic table, the quantum number will tell you. Okay, so let's start with the quantum number. So before starting the quantum number, let us study a little bit about the structure of atom, how the atom exists. Okay, how the atom exists. Okay guys, if possible, I understand with your privacy issues and everything, but if possible, try to give your answer in your own voice. Whatever I ask you, try to give it in your own voice. It will be really interactive session too. Okay, so let us start with the structure of an atom, right? So the structure of an atom, what do you understood by structure of atom? Structure of al zarra, I think atom is zarra. Fine. So the structure of atom, how can you define it? So the structure of atom, it is like always, whenever from childhood, from whatever we study in the school, we study like there is a small nucleus here and the electron are revolving around this. This is what we can think about the atom. This is an atom, right? Now how it comes, how the electrons are revolving, how the proton is there, we will study this. Okay, let's see. normally your teacher tell you that, my friend, this is the electron and this electron is revolving around the atom and round and round and round and finish. This is the atom. Okay, this was the atom when you were child, but right now you are not child, you are grown up, you are a future engineers, right? So for you the atom definition should be nice, should be stronger, right? So let's study about the atom. See, as we know that it has a nucleus, and nucleus has two things, which is neutron and proton. These are the two special things which are inside the nucleus of the atom. Now the electrons are revolving around the nucleus. So Niels Bohr was a scientist who told that there are some shells, there are some circular shells. I am making just a half part of that. These are the shells in which the electrons are revolving around the nucleus inside the atom. Okay, the one thing which I can say, that you tell me, Wallah, you tell me, for example, the electron is here. Okay, electron is here. If I will give this electron money, okay, if I will give money to this electron, so what will happen? Tell me, what do you think? Just tell me. Either tell me in the comment box, or you can just open your chat or anything. If I will give money to this electron, wallah, it's only few days ago you had Eid, okay, and when the elders gave you money, the new dirhams, right? So what you did, you just gone out of the home, you go to the mall, the shopping and restaurants, and you just ran away. Okay, same thing, exactly same thing goes with the electron. So what will happen when I will give money to this electron? In chemistry there is no money, only energy. What? Only energy. So whenever I give the energy to any electron, that is the money for the electron. So electron get powerful, so electron will get excited. Okay, so electron will get excited. Oh my god, it is very excited. So what will happen? It will go away, it will go out. Okay, for example, if I give small energy, it will go a little bit far away. If I give a lot of energy, so what will happen? The electron will go out. Okay, see, the electron will go out, na? Electron will go out. It means the amount of the energy that is given to any atom, so that the electron will come out, that you already know, that is called ionization energy. Ionization energy, it is the amount of the energy that should be given to the electron to remove it from the atom. Same thing what you did in the Eid, when elders gave you money, you came out of the home and roaming here and there and did a lot of parties, right? So same thing happens with the electron. That is called the ionization energy. Just think about the ionization energy. Okay, for example, wallah, there are two students. This is the first student and this is the second student. Okay, everyone knows that if you want to go for a party, for something good, for some enjoyment, normally we think about Dubai. Everyone thinks about Dubai. Okay, so let us consider this one is already living in Dubai, and this one, let us consider this one is living RAK or Sharjah, anywhere. Okay, so tell me, who needs more money to go for a party? Obviously the second one, right? Obviously the second one, because second one is far away from the partying spot. It means that the atom is very smaller, and very smaller atom, the electron to go out, it takes a lot of energy. For anyone which is in already Dubai, so it is the big atom. To go out of the electron, it needs very small amount of energy, it will go out. So this concept starts with the ionization energy, and the factor and the factor on which the ionization energy depends, it is the only one factor, that is the size of the atom. If the size is large, the electron can remove easily, so it means only less amount of the energy is needed. But if we talk about the smaller atom, how the electron can be removed from that? So it means you need a lot of potential, a lot of energy to remove the electron from that. Now tell me guys, is there anything you want to ask about the ionization energy? Did my explanations, they explained you what is ionization energy? Is there any doubt regarding ionization energy? What is ionization energy? On which factor it depends? Tell me. Everything is nice, everything is going fine. Well, everyone should reply. At least there are only few students here, so everyone should reply whether it is yes or it is no. It's fine. Great. Everything is nice. Okay, great. So the concept of the ionization energy, now think about the ionization energy. Think more. Now tell me, wallah, tell me, there is an atom, this atom, and wallah, this atom. This is A, this is B, and this is C. Okay, tell me whose electron can be removed very easily. It means whose ionization energy is very less. Tell me, whose ionization energy is very less? Very good. B. Yes, exactly, B, because it is bigger, right? So from here you just understood ionization energy depends on the size of the atom. Now guys, tell me, for example, if we talk about the periodic table, on moving from left to right in a periodic table, like for example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. On moving from left to right in the periodic table, the atomic size actually decreases. Okay, the atomic size actually decreases. Decreases means this is big and this is smaller, and this is very smaller. It will be like this. Atomic size decreases. Correct. Why this decreases? Maybe you've studied in the previous classes or in the school, but I will tell you, it decreases because, well, lithium, it has only 3 proton and 3 electron. Well, 3 proton, 3 electron, very less attraction, so the size is bigger. Neon, well, 10 proton, 10 electrons, good attraction means the attraction, the size will be the smaller. So that's why we say that on moving from left to right in a periodic table, atomic size decreases. Now, wallah guys, you tell me who has the least ionization energy for among all these second group elements. Who has the least ionization energy among all those elements? Very good. How about the others? Who has the least one? Very good, the lithium. Now you can find the same questions regarding to this in ALEX also. Okay, in ALEX also you will be able to find everything related to them. We will try to solve few questions from ALEX also. Okay, I will search here and I will tell you. Right. So let's continue. So we did a small thing about the ionization energy. Correct. Okay. Now tell me one thing. You tell me, guys. Let us consider lithium, beryllium, and boron. Okay, lithium, beryllium, and boron. Only 3. So as you know that for lithium has the lowest ionization energy, and if we talk about the boron, it has the highest ionization energy. Okay, this is the first thing. The question can come like, what will be the order of ionization energy? Whose ionization energy is the least, or might be possible the whose ionization energy might be higher? So that's how the question can come in your exams. That is come from the ionization energy. Now let's come back to our topic, which was the quantum numbers. So quantum numbers, what was the actually quantum numbers? We just remove an electron from the atom, right? So one thing again come in our mind, where was the electron? How the electron is revolving inside the atom? Now see, one thing you should know that the atom, it has shells. Okay, this is shell number 1, this is shell number 2. Okay, the atom has shell. Shell we call shell is N. Okay, every shell has its own subshell, and we call subshell for L. What is subshell? For example, you live in UAE. Okay, everyone, all of you live in UAE. It means that guys, you live in UAE means you live inside this atom. The first thing. Okay, you live in Abu Dhabi. Fine, you live in Abu Dhabi. Now I will ask you, wallah my friend, where you live in Abu Dhabi? You will say, brother, when you will come to Abu Dhabi, just call for a taxi and ask for Khalifa City. Okay, I will go and I will search for Khalifa City. It means that every shell has a different parts. Okay, every shell has a different parts, and every part is called its subshell. So if we talk about the first shell, obviously it will have some subshell. Second one, it will also have the some subshell. Okay, now I will come to the Khalifa City. Okay, is it possible if I will come to the Khalifa City and I will directly meet you? No, you will tell me, brother, this street, this villa number, and then just come to our entrance, then go to the first floor, and the room number 3, it will be mine. This is how you will explain the address of you. And that is the same thing how we will define the address of electron. How? First you will search for the atom. When you search the atom, then check the shell. When you check the shell, just go inside the shell. You will find the subshell. When you will find the subshell, then you will check which is the room number. Which is room number means who is the orbital, which is M. Okay, and the last thing which is the spin. Spin is S. These are the 4 different quantum numbers, different level of the addresses of the electron, like how and where the electron exists inside the atom. Guys, is there anything you want to ask here? Everything is clear till now? Everything is clear till now? Okay, great. So, okay, fine. These are the shells and subshells and orbitals and everything. Okay. Correct. Now come. Let us consider how the shells and how the subshells are interlinked to each other. One thing, wallah, you always remember. Always remember. For example, if it is the first shell, for example, if it is the first shell, it means that shell number 1, or you can say n is equal to 1. First shell will always have only one subshell. Only one subshell. Okay, first one is have only one subshell. Let us talk about the second one, n equals to 2. So for n equals to 2, it means this, for the second shell, it means that this shell, the first shell, it has only one subshell. For the second one, it has 2 subshell. It has 2 subshells. Let us talk about the n is equal to 3. N is equal to 3 means third shell, it will have 3 subshells. Fourth, 4 subshells. 5 subshells. 6 subshells. Khalas. Tell me, if I talk about the second subshell or second shell, it will have 2 subshells. That's it. Okay, now what are the subshells? What are the subshells? Subshells are also called, one second. Subshells are also called, they are the parts of the shell. How the parts of the shell? Maybe you know about something orbitals. These are the orbitals where actually the electrons are inside the atom. See, the first orbital is s orbital. It is round in shape like this, spherical, okay, always like this. This one is the s, and this is the first one, and for this al is equals to, always and always 0. Okay, s is round in shape or the spherical in shape, and al equals to 0 for this. Let us consider about the p. This is the second subshell or the second orbital or second subshell. This p, this one, this is like a dumbbell. You know, dumbbell, when you go to the gym, there is a dumbbell. So dumbbell is like something like this. Okay, there is a dumbbell like this. Okay, so the p is always like a dumbbell, and for this al is equals to, al equals to 1. Okay, let's talk about the next one. This is d. So the d is the double dumbbell. Double dumbbell means, let us make one dumbbell like this and one dumbbell like this. Okay, double dumbbell. So for this al equals to 2. And the next one is f. Next one is f. Okay, this is the tri-dumbbell. You don't have to remember about the shape of this, and for this al is equals to 3. So this is how these are the orbitals or the subshells present inside the atom. Now, if we talk about the first shell, it has only s. For the second shell, it has s and p. For the third shell, s, p, d. For the fourth one, s, p, d, f. And fifth one, s, p, d, f, and so on. 6 from there. Okay, so this is how. Now see. For example, if you talk about the first one, so it will have only s, which is called the first s, 1s. Let's talk about the 2. So it will be 2s and 2p. Very good. Very nice. Voila. Very nice. Let's talk about the 3. Third shell, 3s and 3p and 3d. Wow. Very good. Let's talk about the fourth one. 4s, 4p, 4d, 4f. Okay. No problem. Very easy. Yes, it is easy. Now, it is the level of the electrons. See, I told you, this is the first shell, this is the second shell, this is the third shell, and this is the fourth shell. Well, you can see that every shell has its different part. It means that every shell has different level. Okay, many of them has the lower level or the lower energy, many of them has the higher energy. Okay, so the energy of this orbital, any orbital of this energy is linked with, the energy is directly proportional with the value of n plus l. If the n plus l value is low, it has the less energy. If the n plus l value is high, it will have high energy. Let's see here. Once again, let's see. I want you to order them inside the energy level. See, I told you guys, for S, right? For S, L was 1, L was 0. For P, L was 1. For D, L was 2. And for F, L was 3. Okay, you know the L value. Now N, what is the N? Well, I told you these are the N values. Now, my friends, just tell me, this has 1 plus 0, 1. Only 1. This energy is 1. This is 2 plus 0, 2. 2 plus 1, 3. So what is the order of energy of 1s, 2s and 2p? Tell me guys. What will be the order of energy of 1s, 2s and 2p? Very simple. Wallah, very simple. How? 1s will have the lowest energy, after that 2s will come, after that 2p will come. You remember there was a question, just same question in your Alex, and you did the same thing here. Do you remember? Do you remember you did the same question in the Alex? How to arrange these things, 2s 3p and everything, how to arrange these things inside the energy, on the basis of the energy, how do we arrange these things? You remember, guys? You did the same question in the Alex in chapter 6. Okay, well, okay, this is how we will do these types of things, these types of the questions. Okay, so now there is some, one second. One second, guys. Okay. Now let's move forward. For this, see. For this is 3 plus 0. Very good. 3 plus 0 is 3. 3 plus 1, it is 4. And 3 plus tell me guys, 3 plus, for D, what will be the value of L? What will be the value of L for 3? What will be the value of L? Is, yeah, very good, 2. So 2 plus 3, which is 5. No problem. Very nice, very good. This is the simple thing. This is 3 and this is 3. Wallah, you know, 2 is small, 3 is big. So 2 will come first and 3 will come later. This is the simple thing, no problem. Okay, now the problem will do now. The problem will arise now. See, this was 5, but wallah, 4s, 4 plus 0, this is 4. Astaghfirullah. What happened? 5 was here and now 4 again came. So it means that if I want to do 4p, 3d and 4s, okay, if I want to do 4p, 3d and 4s, I want to make in the order. So let us do 4 plus 1 is 5, 3 plus 2, which is also 5, 4 plus s, which is, sorry, 4 plus 1, yeah, 4 plus s, this is 4. Now what will happen, wallah? Sorry, this is not 4p, this is 3p. Okay, 3 and 2, 3 and 1, 3p. So 3 plus 1, that is 4. Okay, so now see, for you everything is nice, nothing is new, everything is good. I told you, if they will be same, who will come first? The smaller one, 3p. Okay, no problem. It means that 3p will have the least energy. After that, who will come? Guys, tell me, after that, whose energy will come? Tell me in the comment box, wallah. Who will come after 3p? Very good. The 4s will come. Exactly. The 4s will come. So, after this, the 4s will have. And then 3d will come. Wallah, the order of energy become very disturbed. The order of energy became very disturbed. But when you will see the periodic table, wallah, you will understand why 3p, then 4s, then 3d. I will tell you, wallah, I will tell you. See, let me add an image here. One second. Okay, periodic table is visible to you, everyone. See, guys, see. Starting from here. Okay, starting from here. This is 1s. Okay, no problem. 1s. Okay. This is 2s. Okay. After that, 2p. Okay, after that 2p. Then no problem. This is 3p. Then 3s. Then 3p. After 3p, what will come? 4s, which I told you earlier, 4s. And then after 4s, who will come? 3d. So that's why this d is always n minus 1. It should be the fourth, but no, it is the 3. So this one, this line is always 3d. This one is 4d and this one is 5d and so on. That's why it is like this. Okay, that's why it is like this. Now one more thing I should tell you, then, that there are certain blocks inside the periodic table. These periodic tables have not blocks. What blocks? Yeah, I mean, these periodic tables have different parts. Like Abu Dhabi has different parts, Khalifa City and so on. I don't know a lot of parts, but this periodic table has also had many parts. How? This one, see, this, okay, sorry, some zoom issue. Okay, so yeah, I was telling you, this periodic table has also some parts. How? The first part is this one, 1a and 2a. This part is the s block. Remember, s block. Walla, s, we studied s in the orbitals. Oh my god, whose electron in the s will always come here? Whose final electron, the last electron or the valence electron, will come inside the s? You will find here. And who is here? This is p. This one is the p block. Oh my god, p block. We studied p orbital. Okay, means every atom who has the orbitals, who has the last electron or the valence electron inside the p orbital, you will find only here. And this one is the d. This one is the d. This is s, p and d. And there is also the part, there are two lines here. You will find that will be called the f block of the periodic table. Okay, that will call the f block of the periodic table. So finally we have concluded that the quantum numbers, they tell us about how the electrons are filled inside the atom. I told you how it will fill: 1s, 2s, 2p, 3s, 3p, 4s, 3d. And reason, you know, the energy is directly proportional to n plus l. Reason, you know. So first thing you got, how the electrons are filled inside the atom. The first thing. The second thing you got, how to find the atom inside the periodic table. See, I will tell you how to find the electron in the periodic table. See. Okay. This will be the last part for the today's session. Okay, see how we will find the electron inside the atom. Let us consider I have chlorine. Okay, and the chlorine has atomic number 17. So I want to fill the electrons like in the order we did in the previous. Okay, firstly the electron will fill in the 1s. Okay, then 2s will come. After that, very good, 2p will come. Then 3s will come, and then 3p will come. Let us see. You remember, guys, you always remember, s will always have only maximum 2 electrons, nothing like that. Every s, 1s, 2s, 3s, 4s, 5s, every s will have only maximum 2 electron. So 2 electron here. Okay, how much left? 15 electron left. 15 electron left. Now this is 2. Okay, again 2 electron will come here. So how much left? 13 left. Okay, no problem. P will always have 6 electron inside them. Okay, so we will do minus 6 here. So how much left? How much left? 7. Okay, no problem. S, again 2 electrons will come here, then again do -2, so you will get 5 here. Now only 5 here. P can have more 6 electrons, but it has only 5. No problem, just fill 5 electrons. Just fill the 5 electrons and khalas. Now this is called the electronic configuration of chlorine. Now see, this is very important. Wallah, very important. See, I want you to tell me where is the final electron, where is the valence electron or the final electron of the chlorine is here. You will tell me, sir, the final or the valence electron of the chlorine is in the third shell. See, it is in the third shell, p orbital and 5th number. P orbital and 5th. And when we will check the periodic table, see, the third shell, p orbital and which number? 5th number. Chlorine. Oh my god. That's why periodic table is like this. Okay. That's why the periodic table is like this. One second. Okay guys, so that's why we can see the periodic table like this. If I will ask you, well, tell me, everyone tell me, if I have P5, it means that simple, p orbital and 5th one. Simple, p orbital and 5th one. Let's come to the p orbital. This is the p orbital, and this is the, okay, one second. Okay, what do you mean by the 5th number in the periodic table? Very nice question. I'm just telling you the same thing. That the 5th number means when we will start with the p block. From here, the 5th atom will be the chlorine. From here, it means that first, second, third, 4th and 5th one will be the atom. I told you that was the 3p5. So 3p5 means 3p and 5th one is the chlorine. That is the meaning of the 5. You got my point? One second. Okay guys, you got my point? Yeah, okay, fine. So this is how you will find the electron or in the atom and the atom in the whole periodic table. This is the application and the one of the most important part of the quantum numbers. How many quantum numbers? There are 4 quantum numbers. The first is the shell, the second is the subshell, third is the orbital, and the 4th the spin. We will study them, everything we will study, but in the further sessions. For today, I hope you understood everything, and if you are having any doubt or any query regarding the further classes or everything, just you can ask me, simply ask me. Okay, if you can ask me, if you have anything. So if you are not having anything, then we can just wind up the session, and inshallah we will meet in the next session.